In a world that walks the line, there's a rare few who think outside the box together for the crew. To break the equations, not bound to any rule. Exposing to the world the universe's own view. It takes the talent of the craftsman, it takes the mind of the fool, to make the vision realize energy and matter in a duel. To a break, to a duel. The old man, bills was running through his head. Cheryl probably got it hiding under his bed. Penny up to Annie, making power for days. Don't listen to a word that the straight dope says. Mike building batteries that power a ship. Victor comes and talking math, that's the water spiral dip. Shawn chucking plasma bolts a mile long. Sheila on the video making tones from the throngs. BurnEye breaking matter, they said it couldn't be done. And to all the people in the chat, I know you're having fun. So it's time to spend your Saturday with the doping old man Bill.
What's up, everybody? Oh man, we got this thing messed up today.
Hello,
there
hello.
We go.
This would be hard.
What's going on, guys? Everybody, I'm Nathan, and you guys know that. I'm Old Man Builds. Shawn and Joe, what's up, guys?
Hey, good to be here. Missed you guys.
Happy day after Thanksgiving.
Yes. Great to see you guys in the chat. Thank you for the kind remarks. Awesome.
Right on. Yeah, give me just a second, man. Everybody showed up, man. They're looking forward to when you're here, Shawn. So
Appreciate it.
put up the comments, man. Every time I turn on StreamYard, they keep changing something, put 50 million more buttons on there. It's like the plasma inside the tube. It'll go in that layer of the sphere, and it'll spin like this, okay? And as it does that, you get very high frequency sound, okay? But you're also getting the boundary layers, which is the frequency, okay? And the magnetism within that. But then you take that to the Earth and you look at it and you go, okay, you have each one of those like this, but an anode cathode effect. So when you get storms going on, it brings it down to the layer of the cloud. So now this zone right here is your purple zone between the anode and the cathode, where you can hear the high voltage hiss and everything, where normally it's up here, it's too far away. Okay, but you brought it down here in weather patterns, okay? That's the point. Now you have that in there, so all you need to do is replicate that sound and that magnetism that's going on there in order to get the ball lightning to achieve itself. You just have to think of it the way the Earth does it, then redo it in the lab.
Yeah, I agree with you 100%. That what you're just saying right there was exactly the same exact reason that I was saying to enclose the gravifier and get the materials right, because it's forcing the compression at that point. And that's why you can hear and see literally the frequency change, and quickly and linear, in a very linear and logical way, right?
Yes.
You can hear the pit going up. You can see the light changing color. You know, it's working. And as you know, how do you measure the speed of the rotational force of the RAV? Because we know that that's directly related to the compression. Well, you do it by measuring the frequency bands. That's how you did it, right? So you know that when it's increasing in the frequency, it's increasing in the compression. It's also increasing in its speed. Now, I don't know what the speed would be, but I would gather that you get it to spin fast enough, okay? At that point, it's still laws of physics. You put anything into that type of motion in that state of compression in a high density state, it's going to keep going like that for a little bit. Like that's just, it's got like that momentum.
Spinning it faster, and so it'll spin longer. That's a great analogy, and it's an analogy that directly relates to what you're saying. Get that thing spinning a million hertz, and boom, it can have some sort of momentum. John Bigham puts in the comments, though, that he thinks that they can be self-sustaining. I'm just checking them out while we're talking.
Well, I would agree, but I don't know that they're going to stay forever. And that's the thing we see with ball lightning. It'll dissipate over time. It has to do with how much compression and how much energy you put in the compression and how much time it takes for it to fade away.
Yeah.
But I mean, I don't think they'll stay forever.
Yeah, I think that that's highly dependent on the environment in which it's created. You know, the more stable the environment with the less fluctuation of any given factor, okay,
Mhm.
would immediately place that in a situation where it's going to last much longer, if not indefinitely, under those circumstances.
Oh, if you
But
keep feeding it with the
doesn't, but
environment,
doesn't,
yeah.
but now follow what I'm saying.
Yeah.
But it's actually changing its immediate environment too, right? So it's
Hmm.
just about pushing it further past whatever threshold that is to fully break the locality of it. You see, because that's what makes it then superconductive. Once it's superconductive, okay, it has its own environment that is stable, and
Hmm.
then it can self-sustain, but it's whatever that threshold is of
Yeah.
the difference between it and the environment.
Okay,
The the interesting
so
question though is what happens to the other side of the RAV when it hits that stabilization, because I propose that it actually collapses and combines when that happens.
So if you look at the RAV that had the 0.16 millimeter wire and it's balancing on that, you get a pretty much almost 360-degree view of the RAV. So when you're talking about the bottom of the RAV, are you talking about the inside of the RAV or are you talking about the actual bottom of it?
In what context? I'm sorry. I don't know.
Yeah, you had mentioned that you're seeing the RAV. Forgive me, I am very having a tough time. You mentioned that something about this is what is going on the outside of the RAV or top of the RAV, but then you said something
Okay,
about
pardon me. Okay, so what I was saying
the
below it.
other
Well,
side.
okay, no, I got you now. So to clarify, what I mean is, we obviously know that what's going on is inverse on the cathode side. It's what we see. It's what the theory said before we said anything. You know,
Yeah.
what I was saying is, we know that that's going on below. Now, what I've proposed in the past, right, is that when you have the breakdown of the molecule down to the molecular level, like, a compound to a molecule, and then or broken off a lattice, one or the other, right? Same
Right.
thing mostly. Then you have that breakdown into its electrons and its atomic mass. You have them separate. Okay, so now you have this high energy state, low energy state separate of each other. It's what it's doing. Now, what I'm proposing is that once you cross the threshold, when you break locality, that those sides actually reculminate, okay,
Okay.
into, and that would be the fusion event, by the way. Be clear, okay? So the low
Uh-huh.
energy nuclear reaction that we're currently having, okay, is less. I'm not saying it's not transmutive, okay, at all. But
Sounds
what
like
I'm saying is that the transmutation that's occurring is occurring intramedia through the exchange. Okay, whereas if you actually cross this threshold, you'd bring your atomic mass side in to combine with the high energy side, which is their original state. And then whatever resonance that they have is a beat frequency between the two. Okay, the offset differential, right, would be deterministic of their structuring into new matter. Does that make sense?
Yeah.
Whatever that threshold is, it would also break locality and become self-sustaining at that point, act as a vacuum in a pump, and just start accumulating is what it would do.
And
I think.
could you relate what you just said to actually what we're seeing with the crystalline?
Ab- Absolutely. So when you hear the pitch go up and you see the colors change and you see the structuring on one side and the RAV on the other, if you were to push it further past an unknown threshold that I believe to exist, okay?
Mm-hmm.
Once you pass that threshold, I would believe that the compression of both sides would become so much that the magnetic fields and how they're interacting, rather than work like a figure eight, okay, they would actually combine, and it would then create upper dimensionality again. Because remember, this is all energy vectoring, okay?
Okay.
Oh, Joe froze.
I was gonna say pause.
Static. Yeah.
sorry. Sorry, Joe.
You haven't frozen yet, Joe?
Whatever.
You froze.
You
You were,
froze.
you were making poses because you froze.
So anyway, it all has to do with energy vectoring, right? So if you and energy vectoring and dimensionality are directly in relationship with one another. So what you start to understand is that static is one dimension and then current is two. Then when you take two dimensions and you bring it into a magnetic component, it becomes three, then four. When you bring them all together, they're all each individual bit plus the sum of all, right? But they don't ever cross over that fourth dimension. Now, when you take these things and then they're split and then you bring them back together, you've actually taken it and put it to the power of two. Okay. So once you put it to the power of two, all of a sudden your mass reaccumulates. You have new time um, variations that would be involved because, and this is different than the ambient environment because the ambient environment around it is, we'll call it three dimensional, subject to the fourth. Okay. But this would be to the fourth square, to the second power. So because it's made in this dimension, but then it's split apart and recombined, it then goes up in orders of magnitude. So you're dealing with higher dimensionality. What that means is that you have a separate time situation, you have a separate gravity situation, you have a separate mass and density situation. That's what I theorize. This is on the fly. It's just what I'm thinking. I don't know.
No,
Hold on. You do realize when you're talking about the sphere of the Earth and stuff like that, for every layer of energy that you put in there, it has a time dilation field. The time dilation field is directly related to the frequency because it's F equals 1 over T. So every layer has its own time. And the further distance you get from the center layer to the outer layer, the time changes. That's why you'd have to redo all your satellites in order to get GPS to work.
That's right.
It's in physics. It's all in there, and you're right. But you got to remember when you're talking about the different time and stuff like that, it's because each layer has a different frequency. So when Shawn builds out 94 kilohertz over to 98 kilohertz over to what was it, 102 kilohertz, those are his three frequencies he came up with. Every one of them has its own time dilation field inside of it based on F equals 1 over T. So that's absolutely perfect in physics the way it works out.
Yeah.
Mhm.
But that's why each layer that you go up in the Earth has a different frequency because they're built out that way. But
Yeah.
that's the anode and cathode effect in the RAV. It's perfect planetary physics.
Right. So we keep on saying this over and over again for almost 2 years now, a year and a half, whatever. Break locality. But what does that mean? Well, it's really, you could describe what the effect of breaking locality would be, but how to do it has been a little elusive to put into words. But this is now built up to the point where we're able to now articulate what that means. It means that okay, it's broken. We've broken it down, right?
Okay.
You could see it. You could now see it start to build back up. And then you have to bear in mind where you are in the relationship of where you are and what it's doing versus what you're doing right here in this closed system, right? And once that occurs and you break it apart, separate it, have it work together in an exchange, but then recombine it, now you have the fusion event. That fusion event is not subject to the same reality that we're sitting in right now. And that's not.
Yeah, I think fusion breaks quantum mechanics because it's the quantum tunneling for hydrogen atoms to become helium. So is that what you're talking about when it breaks?
Well,
Buddy?
yeah, that's like a more controlled and unusual state. This is more dynamic than that.
Yeah.
Because it's not a chemical reaction. It is a chemical reaction, but the quantum tunneling factor of it, you're already seeing that. How do you think the electron gets through your ceramic that's non-conductive. Well, the fact is that nothing is non-conductive until it is, right? So whenever you put something past a certain threshold, we refer to it as an insulator because under common use it is. But
Right,
this is
right.
no longer common use because you're taking super high energy potentials
Yeah.
and you're compressing them, and then you're putting them into direct contact with it. That ceramic is as good as a conductor to that energy state. Nothing is totally immune to conductivity. It's just under normal use. So that's really what you're looking at in that situation. Pretty
That's well
crazy.
said. It's well said. I just needed the ceramic to conduct for my experiment. And I couldn't until I added water. And then when I got it conducting, oh, good. Cool. Now I can actually run my experiment. But you're bringing me back to actually what it's doing.
Yeah,
And
right.
it's
Sean,
fascinating.
why did it not until you added water? Because you knew to add water, but why not? I know why.
I knew water would be the in-between conductor to facilitate the friction that the high voltage would cause to heat up the ceramic. So, I mean,
Because the water is able to be broken down into a high energy potential state. Okay,
yeah.
where the valence electrons can be stripped off of the two hydrogen atoms or two hydrogen molecules. Okay, and then it works both ways. The tunneling, once it's broken down at those high energy states, once it becomes conductive, okay,
Mhm.
all of your low energy state atomic mass, okay, can be transient through that material, the same as you could look at helium and stuff like that drip liquid through a solid at superconductive states.
Mhm.
That's what it is. It no longer is subject to the barriers in which it was previously because it's approaching a superconductive state.
So let me
Right.
shout out Merkaba real quick. Okay, he did a couple of videos and I sent them to you guys.
Yeah, they were
Please
good.
just understand what he's trying to tell you is the sonic or the ultrasound going off in the sonic level, just like the RAV going in the states in the sphere it goes into and the rotation of it. It's doing the same thing. So it's becoming superconductive based on that. And it's forming new elements inside of it that come out as our satellites. Okay. That's why that video was important. If you picked up on it, what he's trying to say is the transmutation that you're seeing is perfectly fine in the way the world works. He's using mercury as the medium, but we don't have to. We have the original medium, which is plasma, which allows for this. So what we're seeing is every time the satellite forms, you get a little bit of a leakage, but the leakage swirls and it becomes that little satellite. But in all things, it's all the same thing. They're all building out, okay, as an electron. This builds out an electron, and along the line of the electron, you build a secondary electron, okay? Then it builds out, and you have other lines of the electron, and it builds out another electron, okay? But every single one of those is known in physics. They keep calling them different things and it screws people up. This is why I have
Mhm.
trouble with, uh, you know, you start saying wire and it travels electrons in a wire and it doesn't work that way. It needs a swirl in the frequency and it needs to be trapped outside the wire at a higher voltage in order to get an electron. I don't believe they're inside the wire at all because what energy doesn't travel inside the wire, it travels outside the wire at all times. It's just the amount of distance from the wire. The it's a total
Yeah.
different structure when you start to look at it. You know, they build them out and we can clearly see it. I mean, in the RAV, you can clearly see it. There is no question about what the electron does. And if you want to say it does what the atom does, then you say, okay, what's in the center? Is it only hydrogen? Is it helium? Or is it changing based on the what you started with? So if you got the RAV to build out in the 90 kilohertz, did you do hydrogen? If you did 150 kilohertz, is it something else? There's a relationship here at all times. And the only way to continue to keep a RAV self-sustaining, by the way, is to have a resonance frequency outside the RAV that matches the RAV, that keeps the speed of the RAV continuous based on the resonance frequency. If not for that, then everything runs into impedance and slows and stops. It's the resonance frequency outside the RAV that continues the rotation of the RAV based on that resonance frequency. It's the same thing as a node in the center of a Tesla coil. It builds out the exact same way. Why?
Yeah.
Because they're all particles. What we call particles is the same thing as an electron. It all builds a simple electric shell around it. So how do you beat gravity? You have to create an electric shell that does the exact same factor. You must create gravity in order to beat gravity, which means you must create an electron shell
Makes sense.
based around something. So static electricity structures air around it. But that also means that voltage in water structures water around it. So how do I go from the up in the atmosphere, so down in the water, in a correct path? I must structure both at the same time based on that knowledge. One's in high voltage, one's in low voltage. You automatically create the bridge and go wherever the heck you want because you don't have impedance. How do I create an Einstein-Rosen bridge? I open it at one side and it opens in the other between the two layers going on in here. Now I can go right through it. It's the same physics. But how do I go from our solar system to another solar system? I simply use the same formula in physics to go from one to the next. So when we write out the physics formula for gravity, which we must understand, and which I did add when I wrote mine, is we have to have entropy in it. You have to have radiation as a not as a factor of building, but it's going to be what happens when you build. So it's always going to be in every electricity system, no matter what you do. Once you understand those things, then you can start writing the true gravity equation. Guys, I've written mine, and I can tell you this right now. It's awesome.
I'm gonna make a huge claim, and
Go ahead.
it's a shame that there's not a few thousand people watching right now to hear the claim, but this is superconductivity. Okay, this is, and by the way, this is a really radical claim now, is that this is also room temperature superconductivity, even though it's hot. And I could explain why, right? Well, first of all, why is it superconductivity? Well, what is superconductivity? Usually they have to cool something down to damn near absolute zero. And why? Well, to achieve one part, at least, right, that is in the lowest possible energy state. So we're already doing that. And then where's your differential come from? Well, your differential comes from the hot on the other side. Okay, so that in itself is superconductivity, because you have that super low energy state with the high differential high energy state on the other side. Now, why is it room temperature? Well, because the sum of both is the ambient. Okay, so when you take the cool side and you take the hot side, and then you combine those two together, all you're left with is the ambient zero. That's why.
Yeah.
You see?
Yeah.
It's not that it's at the temperature of your room, it's that the sum is that at zero. Now, why is what they do in a laboratory with supercooling liquid nitrogen, etc., whatever they do, why is that not room temperature? Well, because there's only one differential that's that low, and the other one that's room temperature. So that drops the temperature way down below ambient, way below room temperature. But when you take something that should be, right, it should be like 50,000 degrees, but it's not. Instead, it's 2,000. But then you have something on the other side that's much cooler, right? Maybe not minus 2,000. What you notice is that the band is like this, In other words, your differentials are close enough that it's closer to ambient temperature. And nobody ever said, well, if you got something doing negative 100 degrees or 220 degrees, that's not room temperature superconductivity. Nobody's worried about those temperatures. It's only because it's on the extremes that they ever talk about it.
Yeah,
Right.
it's the exchange. That's
It's the
entropy,
exchange, right? It's
but it's
the
entropy.
separation, the
That's
exchange, the breaking apart. So now, like I said earlier, right? That's cool. Superconductivity is the breaking apart, the separation of, and fusion is the bringing back together of. And once you break something apart and then put it back together, now you have a whole entire new self-sustained situation. I believe that the self-sustained situation is resolved at that threshold.
Hmm.
Whatever that is, I don't know what it is. I wish I
I,
did.
I'm
Yeah.
gonna. I'm just gonna go out and say this, and it's based on experiments I've done. I have never seen anything sustain itself in energy without a source. And but let me clarify what I'm saying. You must have a center source that goes out to everything, and then it returns back to the source to self-sustain it. Okay, so you can't have something by itself without one feeding something else or two being fed by something else in the system. Okay,
Mhm.
that's what I'm trying to say. Because all energy is borrowed from the source in our whole cosmos, then it returns back to the source. Okay, but it amplifies by the amount of things it builds outside the source. That's how it gets bigger. Okay, that's how it keeps building more. Just understand this. It goes back to the Tesla coil thing. You build out a primary Tesla coil, you put a secondary out there, it'll start. But then I can add a whole row around it of secondaries. Then I can hold another row around it of it. It's all
Yeah.
borrowed from the center one. But then it all
Yeah.
returns back to the center one.
Yeah,
It
it's
it
it's like some remarkable form of like molecular sublimation,
it's
where it's like,
entanglement. They're all entangled. You can't get away from it.
well, I mean, it's of course it's entangled. You ripped apart something that was never supposed to be broken.
Well, yeah,
So what
but
does it do? It's like, let's get back together, but then it's in some kind of weird current state because of all the presence of every mode of electromagnetism in the proper proportions, right? All the vectoring. So everything follows like it's like stuck in a pipe, right? It's kind of like if you were to take two magnets and put one inside of a pipe, one outside of a pipe, and then move it. The other one's going to go with it, but like they're not touching.
yeah.
It's kind of like that deal. That's sort of what's going on here. It's just
Okay,
not so literally.
one thing I will caution you in getting into this: do not define or misdefine radiation and magnetism, because there's a very fine line there. Okay, as you build out in higher voltages, the magnetism becomes more radiation than anything. So when you get out to the outside of our planet, we don't have things falling in there. You know what I mean? Based on the magnetism level, there's radiation out there. It's almost the same field. It just builds one higher value than the next. Just remember that when you go to put it in perspective, because people think it's all magnetism, so therefore outside of our planet, you know what I mean, we could sling magnets at 1 billion miles an hour just by going around them, right? No, it doesn't work that way. It's mostly in radiation form at that point, which is
Hmm.
on the other side of magnetism, which means they couple together at all times. And by the way, just so everybody knows, if you think voltage is simply frequency, voltage, and amps, and it doesn't have entropy and it doesn't have radiation in it, you know what I mean? If you think that that's possible, then you better relearn how the energy works, because they're in there at all times. Sometimes they're just dormant. And
Yep.
because you don't know that, all your physics formulas get ruined. And then you start creating math that has to reverse the other math in order to cancel the math out. That's why it doesn't work.
Here, let's use common sense for a second. If you have a regular old magnetic field, like a regular one that like could like suck a car to it, you know what I mean, and like swing it and then yoink it, right? Give
Mhm.
it the yeet skis. All right.
But
If you have
magnetic
if you
fields are
have
finite. They
so Right. So if you have that kind of electromagnet, okay, though, with a traditional field, right? If you placed another um form of magnetism, okay, that was smaller in the center of its own power source, okay, and as an offset differential of it, okay, there's going to be a point of interaction that's on at probably 3 points, I would say, um, around the sphere, where it's actually going to put off radiation because it'll the smaller field in the middle will actually work screw with the eddy currents inside of the other one, revector them, and throw them out as scalar. That scalar will collapse as it's exiting the field and be thrown off as a form of radiation. I don't know shit, but that sounds right to me.
How would you bring that to a like on your bench kind of experiment? Because it is fascinating.
Make a big electromagnet and then put a powerful but small electromagnet inside of it. So make a ring and then put another one in the middle of the ring and then allow the first one to build out and then crank the second one. That's what
And
I
you think
think.
you'd
And I
have
think you would see,
radiation?
yeah, I think you would get equatorial radiation.
Hmm.
Okay, and then I think you would get also you would get like tropic, if you want to think about it in terms of like the Earth, right? You get
Uh,
tropic radiation as well. So
John,
you'd get
sorry,
the three rings.
I'm laughing a little bit. Okay, so just understand what you just said. Big electromagnet on the outside, small electromagnet on the inside, and you get radiation, right? Okay, that's a sum. What do you think a Tesla coil is with the wire down the center of it?
Hmm.
Just throwing it
Oh,
out there for you. You basically have an impulse
oh,
radiation because you're forcing the energy inside the wire itself, right? Therefore,
Hmm.
you've done your radiation homework
Hmm.
and you have an impulse field which is 10 times stronger than a pulsed field. So yes, it's
Yeah.
definitely ties into radiation with magnetism. That's why I tell you, don't mistake one with the other because your sheath layer is radiation and magnetism combined
Mhm.
in that layer. Okay, but it's an impulse, so it's an impulsed radiation. It's a holding
Absolutely.
in field. Just,
Now,
just, so, you know,
counterwound
it right
if you
there.
counterwound the inner coil and then powered it on to its own self, not relying on resonance though, so it actually had some push of its own that was not necessarily resonantly coherent, okay, it would actually blast it out also in an offset pulse, okay, but in a more diffuse way. So rather than have it broken up into three lines where it's shooting out because it's in it's in sync somewhat with the rotational force, you'd get that counter rotational force would actually start whipping it out. Like
It
that's my theory at least.
it
Mhm.
causes it to go into to an AC pulse.
Yeah,
Okay,
it would
pulses.
go into it would spray in a pulse, but a rotational pulse though. So it would be like spinning a bottle with holes in it, and it would just be fucking pissing out as you. That's what I think.
Well, we've done the test. I have. I put a
Yeah,
coil
I
inside of a
know.
coil. I've counter rotated the coil. I can tell you exactly what it's doing. It's creating AC. It's a slush. It goes back and forth. That's what AC. AC is not a. It's a
Yep.
slush.
Hmm.
Like a water slushing back and forth.
Yeah, it's a big
Yeah.
slushy. Be slushy, slushy.
I just
Yeah,
sent you
So
something.
there you go.
I sent you a video, Nathan,
yeah. Let me pull it up.
that I think is interesting because I didn't get to share, but I like your input. How you guys talk about the frequencies are part of building out the RAV. This is the spectrum analyzer that I'm still learning how to use, but I'm measuring I put a low, I forget, I put basically a probe that's an antenna, and each one of those peaks is a frequency. So there's many frequencies coming from the RAV that
Mhm.
we aren't quite understanding because they weren't picked up anywhere else.
Look at
So
that curve, man.
so I'm burning the RAV down there, so you can see it. But then if you go because a spectrum analyzer is not like an O-scope, whereas the O-scope shows positive and negative sine wave up and down. The spectrum analyzer says for each peak that's a frequency, and the higher the peak, the higher the peak, the stronger the frequency. And I set the range from 3 kilohertz to 1,000,000 or 1 megahertz. So that's what's going on between 3 kilohertz and 1 megahertz. If you want to kind of freeze it there, Nathan, pause it.
I mean, I don't know anything too much about how those scopes work, but what that looks like to me is you have like nodes of stability and then anti-nodes of fluctuation.
That's interesting.
It's like hitting those marks, but then your other marks, they're there, but they're in a state of fluctuation. That's just such a weird waveform, I know it's not a linear waveform, like you just said. I'm aware of that, but I'm saying like where it reduces, it's noise.
Yeah, it's got a lot of noise in between the peaks. You're right.
That's what I'm saying. Yeah, I don't know if that's standard or what. I don't know, but
it seems like because there's no noise-free environment ever, I think we probably could rule them out. But those peaks right there, you can't rule out, because normally when you're measuring something, it'll have a primary frequency and then it'll have a few harmonics, but these are all equally peaked. And each hump
it's so regular. Yeah, it's so regular.
Exactly. Yeah. So one hump you could say is 100 kilohertz. Next hump is 200 kilohertz. The next hump is 400 kilohertz. Each hump climbs up to the megahertz.
All right, I have a question for you, Shawn, but I need to take a 2-minute break. I'll be right back.
Sure.
I have your answer. You want to know what the answer is?
Yeah, that's why I brought it up. Tell me. Can't wait.
Okay. Take your capacitor bank to your testicle and run it, and you're going to find different zones in which the frequency itself will hit a resonance level. It'll peak. Yeah. Then it'll go down towards the static. Then it'll peak when it hits a secondary resonance level. Okay. I have a coil that I set it up on, and I'll hit it at about 250. I'll hit it at 450. I'll hit it at 750, and then I'll hit it at 1250. Okay.
It's doing the same thing here.
Every single one of those is my spike, and everyone in between is just noise because it won't do anything. That's exactly what it is. It goes back to how you see your testicle built out. Most people think that a testicle is one frequency, and that's the amplification. It's not. There's a ton of them in there. It's like radio frequency in your testicle. When you go to look it up, which one is my correct frequency? Well, one's the highest amplitude frequency, but the other ones are still resonance frequencies inside the testicle.
That's right.
So it's just just like Limited State says, it's like AM radio tuning. Every single one of them is a station. Only one comes in real good on your AM dial.
Yep, makes sense. Yep,
that's the answer.
Makes sense.
I do this every day, Shawn.
No, I know. I'm just catching up to you. So
yeah,
what do you think the next steps are? Well, actually, there's a couple questions in the comments, if you don't mind.
Go for it. Oh, hold on. Before I get there, I need to do this, okay? Darren, I want to say thank you earlier at the beginning of the show. He came out, man, with a $5 sticker. I want to say thank you to Darren.
Awesome, Darren.
Right on.
Darren.
There was a comment that I wanted you to get to, 2 of them from the same person, Shawn, right here.
Okay.
Are you familiar with with Dr. Jonathan Phillips at Naval Postgraduate School on super dielectric materials?
No, I haven't heard of them.
Okay, so you may want to note that.
I don't watch news. I don't read. No. Thank you for that. I'm going to write it down. Dr. Jonathan Phillips. Thank you so much.
And he gave a little more expression on what that meant.
I'm just going to write it down here real quick.
Oh, sorry. I'll put it back up.
I just want to see.
Jonathan Phillips.
Super dielectric material.
It makes a lot of sense to me already why he's asking, and the next
Okay.
sentence will make even more sense why.
Okay. I'm good. Thank you.
Okay. It's basically has to do with the capacitors.
Mhm.
And we already know that this thing is one big giant capacitor. I'm, I'm sorry, but you could test the frequency of each layer of a capacitor. And I'm
Mhm.
laughing because you could do it in aluminum layers on a high voltage capacitor and get the same answer, which
Mhm.
means energy completely repeats itself. And we keep doing the same thing over and over and over again. And I find it hilarious because I guess I'm like one of the few people in the room that see it. And everybody else keeps trying to call it everything else. And I'm going, but but that's my diode, that's my capacitor. You know what I mean? That's the
Mhm.
same thing we're creating in the RAV, but that's my planetary structure, but that's my atom. And I go, you do know we're just swirling energy around in circles. I mean, for God's sakes, it ain't changing.
You
Anyway,
want to know something? When I started overpowering my system when I was making it, uh, one of the ways that I did it, and one of the ways that I got a much less powerful system to actually do it too, was to take tinfoil and then make a mini capacitor, and then take a carbon ceramic, basically a lead blank for a pencil, like a thick one,
mm-hmm.
and then stick it right up the ass of it, and then just hook my positive power supply to the outside of the foil, and then I just put it inside of a shrink tube, just compress it, and
So
shoved it in there, and then crunched it together, and then as soon as I started doing that, it would build up. It like lower voltage, take longer to build up though, rightfully so. Makes sense, doesn't it?
so
And
Joe's
then
over here making a Schnubber circuit without knowing it.
yeah, then it was just repeating that process just again is what it was doing. Yeah,
Well, yeah, but
exactly.
what the snubber circuit does is it's a bleeder. So high voltage comes back in compression and goes back to that and gets you filled up your capacitor, and then you're able to put it back into the normal system, right? Well, that's what all the snubber circuit does. What Shawn
Yep.
and I were talking about online with that was, what if we took that amount that came back in compression and then we put it towards another cap bank, let it fill up, and then we hit the button and push it back to the normal system on the outside going through the number two. We can then
Mhm.
create an amplification of everything going through it. So when
I
you
can
see
see
the
that.
RAV and it goes like this and it amplifies and you see the range come out, well, what do you think you're doing? I mean, when you hit that button. But now, if we only do it on the top, what do we have? We have a vector direction. Now we know we go up. It instead of all this, it comes out like this.
Mhm.
That's that's the key to moving an anti-gravity. You just got to think of where the energy is.
So
Mhm.
the phase zapper, the phase zapper test.
Shawn got us both with that, by the way. Shawn made us zap both of our faces with that thing.
Amen. So check this out. I did what I just told you with the foil and the all that shit. I did that twice. Okay. I crammed it right up the rear end of that thing where like you're supposed to put the tubes.
Hmm.
Then I ran that to a wire and then had another one hooked up directly to an anode. And what you do is you turn it on, you don't touch it. Okay. You turn it on and you let it go. You can't just go right into it. You got to let it go for like a minute or two, and then what you do is you introduce whatever you're bringing, you do that. And then what it does is it starts discharging, but it starts discharging it at this rate that is with the resonance of what it's putting through. So it's kind of giving it to you full, but it's like a squirt gun that keeps on refilling. It's always under pressure. So it's just pressing and pressing and pressing and pressing.
Mhm.
And, you start doing some crazy shit that way. And you start to realize real quick, wow, this thing probably lethal. I don't know.
Well, yeah. I mean, I don't know if
Have
you
you
realize.
been bit by it? Has it
Not
been
like
you?
that. I was pretty cautious and I kind of knew what I was getting into, so I wasn't trying to find out.
Right.
But
Like like Nathan.
I
yeah,
got bit by it. Yeah, it's not
You
that
got bit
bad.
by it?
Yeah, it's not as bad as you think it would be.
yeah.
Yeah.
No, I mean, I've done stupid shit like get hit with it with no tube, and stuff but with no capacitor things in it.
Oh, I
You
full
know,
on grabbed it. Yeah, it gets
yeah,
you. Make sure you use one hand.
mm,
Hey, I
yeah.
Nathan,
wanted
have
to.
you
No,
been shocked?
listen, knock wood, but any of the dumb shit I've done, I have never paid the price for it. So
Smart. Smart. Nathan, have you been bit by the flyback?
By the flyback.
The high voltage?
Yes,
That hurts.
yes.
That hurts. I had
It
a
hurts like
spark
it's
gap.
it hurts because it's AC. We're kidding.
I had a spark gap. I had rubber gloves on. I grabbed one end of the spark gap with my
Oh,
gloved hand, the other end, and it ignored my gloves, went right through my arms.
oh
I thought
yeah.
it stopped my heart.
oh, Jesus.
I was like,
Shawn,
oh my goodness. Thankfully, the current's low. I mean, I don't recommend it. You'd probably kill your pacemaker or something. But yeah, that hurt.
yeah, it sounds pretty unpleasant, man. That's
All right, guys. Real quick, I want to give a shout out right here to Deadfish Cheese Bread. Man, he's doing another documentary on the orange crystal orbs.
Ooh,
So the last one was really good. Joe was
very
raving about it all
cool.
day
oh,
when he put it
it was
out.
great. Educational, told the story, and was wildly entertaining all at the same time. It was great.
Do you have
Oh
a
yeah,
link?
yeah.
Nathan, do you have a link to his channel?
Give me a second and I'll get it for you. Put it in
Awesome.
there. I wanted to make sure I showed those things, guys. Let me pull that up for you.
See, John Bigham says the reason why a system cannot be over 100% efficient is because they are cyclic and cycle is internally bound or coupled. If you could decouple the energy from the source, it can be looped.
I mean, I tend to agree with that. That's a lot of what we
Yeah.
were saying too about like when we were
Yeah.
talking about the RAV being a well. Does that make sense to everybody a little bit more now? How we were saying it's a well, how it splits everything apart, keeps it all together, stores the high energy. It- you know,
It
uh,
makes sense.
in the density. That's how it's a well.
So real quick,
Technically, you could probably loop it at that point. You know what I mean? Just because you have the well. Without that, I don't think you could do it.
real
Yeah.
quick. The link is in the chat right there.
Thank you. I just
Shawn,
subscribed.
oh, okay. Wanna make
Awesome.
sure you guys got
Thank
it.
you. I'm a new subscriber, Deadfish. Can't wait to see your stuff. If you guys want to share your links, I mean, if it's okay with Nathan, we'd like to see how you're doing.
Yeah, just tell me about it or send it to my email and I'll put it in during the show. I
Yeah.
leave that undone like that because we get a lot of spam stuff in there.
Right.
So I don't allow people to put links in normally. So, but we all agreed between Joe and I on his last one was really good, and he actually won the Tesla coil in the weight contest. Yeah. So and then his orb video is amazing, by the way. When he shows the crystal and it shoots off. So when you get that on the shorts, you'll trip out on that, Shawn.
Yeah.
Oh yeah, and I have I actually have slowed down footage of that I also modified, and there is some weird structure-y thing going on underneath that orb, like a cube. It looks like a cube. I sent it to Deadfish. He saw it, but it's like a multicolored cube that reveals itself when you mess with the levels if you pause it at the right moment. Actually, if you, no matter when you pause it, frankly, but I was able to get it on a few different stills, clear as day.
I'll slow it down and put it out
Very
there then.
geometric. It's like there, and let's put it this way. You'd never fake anything like that because you see his video and it's literally just
Wow.
the video, right?
Yeah, who knows how to slow it? Yeah, and look for it.
And right, who's gonna stop it and then oversaturate it and then blow out the levels and then to reveal something that is clearly not there.
Wow.
Like
Well,
it's yeah.
Can't wait to see it.
Here you go. Let me show you it happening in slow motion and when things appear.
Hey, thank you, John. I'll be safe with one hand, brother. Thank you.
Look at that. In full speed, you can't see the dots. In slow motion,
It's so
they
crazy.
appear with
Yeah,
the fields
look at
around
that.
them and everything.
And by the way, what side of that is it? Have we been saying that shows the other side, right? That's what we've been saying all along. What is on the other side?
So crazy.
Atomic mass. How do atoms arrange themselves? Just like that. Look at an electron microscope. It's macroscopically showing you what the atoms are doing.
That's so crazy.
So look at the
Yeah.
figure. You got cubes in there. You got
Yeah.
triangles. They might even. I don't know, man. It kind of. Not exactly a Merkaba, but it's kind of
Well,
close, man.
hold
Double
on.
triangles.
Give me a sec here. I'm looking close at it. Give me 1 sec.
When you look at the patterns,
It's
that
5. It's 5 and 3 is how that's structured. If it had one more, it would
There's
actually.
one at the bottom. There's one at the
There is
bottom.
one at the bottom. So I mean, the way that's structuring is actually like what we've been saying all along, like the Kagome lattice. Yeah.
I try to tell people.
Yeah.
when people go, oh, it's a lens effect. Well, how do you break apart light to understand it? You use lenses. I mean,
Yep.
it's like, of course, it's the lens effect. We use lens effects all the time. My spectrometer is a lens effect. It breaks up
So hold
light.
on with the lens effect, Nathan. I think you showed it the other day. I'm not sure, but can you show it again? You know which one I'm talking about.
Yeah. But I just wanted to show you this. Let me play it a little bit.
Okay.
Just so you know, look at the little thing shooting off of it.
Oh.
Okay, maybe it's not this one. Hold on. There it goes. It's shooting them off, right?
It's not even connected at the anode there. Look at that. Oh, that thing is mad.
Okay, but look what just happened.
I know.
That right there just went into that little ball right there with its own field separate from the main field of the RAV. You just got what you wanted in the other video. You just got it converted to plasma right there. You literally converted your gaseous state into a plasma state. Okay? Just understand that you already have transmutation before we even got to crystals. Okay? We take light, we bring it in, and we get gas. Gas brings out light. You have light. Light goes into plasma. Plasma forms in this thing right here, which is the center point, which breaks things down, and then it converts it to new stuff, which is crystal.
Yeah,
That's how transmutation works. Yeah, we have it. We have it all.
Yep.
There's no question about it. It's on video. We have it all. We have transmutation exactly from start to finish. I mean,
oh yeah, it was just blasting out the sides of it in every single direction.
yeah, but those worm things are okay. So you talked about the worms going on in fusion, right? And how they come out, what those little blasting things are. Well, just think of those as they haven't hit the outside ring yet to form the satellite yet. So either they come out in a little spring shape, or they turn and spin and become satellites. Either way, that's the way it's going. You know what I mean? It's trying to spin. It's going in circular fashion. It doesn't quite form. And it comes out as a spring, but then comes back just like the the little fractals that come out, you know what I mean, as the snowflakes that we keep seeing,
Mhm.
and then they suck back in because they haven't fully formed yet.
I mean, so
They're
what does that say
it's like
about
a baby nursery of it.
so what does that say about laser patterning? Because that's what that looked like, is a laser pattern. You know, like if you have a
Yeah,
green, right?
I
So what
told
does
you
that
what,
say about that? Does that
Joe.
mean that you could split apart a laser through a filter in a certain lattice pattern and just get that out? You know what I mean?
Okay,
Like, does that mean that? Like, I don't know. I'm trying to digest it.
you're literally taking sound and light and swirling it. This is the
Mhm.
point. But this is the point. It's all the same freaking thing.
Oh, right. I
Again,
know.
it's how much you adjust each portion of each thing. Okay, how much entropy did you put in? How much radiation did you put in? How much magnetism at that point? Because it'll go from a sound wave to a light wave. Okay, then it goes. You know what I mean? It's changing based on those things that'll create gas in between. Gas now lights up because of it. So now you get what I'm saying? There's
Mhm.
ways that it changes, but it all has to do with they're all in there at all times. You
Mhm.
simply amplifying a little bit more of one and then amplifying a little more of the other. That's how it all works. That's the whole shebang right there. That's how
Mhm.
energy works. The problem is when you go back to Maxwell's equations, he didn't know it because Faraday didn't know it. Okay. But when other people start putting it out, they're not realizing those things. So when I tell you there's entropy in it from the beginning, I could play with the heat in your electrical system and completely change every value. Okay. I could do it with frequency. Shawn and I were laughing our butts off. We go, DC has frequency. And Shawn goes, what'd you tell me?
No, it doesn't. I said, no, DC does not have frequency. When Nathan goes, well, I'm going to Google it. And so Nathan Googles it, and Google says DC has 0 hertz. And I said, see, Nathan? And he said, and then Nathan started showing me examples where DC has frequency. So he proved me and Google wrong.
Yeah. So, but right. That's
So,
a both because DC in its native state is in a static state, and in order for it to be usable, you have to move it. And in order for you to move it, it has to have a frequency as a carrier because without it, then it's not in motion.
okay.
So that's
So, so
And it's
let
always
me
moving.
break this to you. This is the same thing a magnet does. Okay. They're going to tell you a magnet has a pulse only. So it's a PWM. It is a set frequency at a set height in there. It's a moment in time. Okay. Just understand what I'm trying to say to you. But that's exactly what they say DC is until you start converting the amperage to voltage by changing the frequency. But then you think about it, what do you do in the meg to make it work right? It is that same structure in a magnet that you're playing with. I am now changing the frequency of the meg in order to get my magnetism out of my magnet. Okay? Just understand what I'm trying to tell you. That same trick works in the same
Yeah.
way there. Now you understand that there's a correlation. I literally can change your system based on knowing this, okay? Because it's not that it doesn't have a frequency, it has a set value, okay? And that set value is how many volts and how many amps you have in the system. That's what the pulse rate is telling you, but it still has frequency because
Yeah.
frequency will change all things. And if
Mhm.
it didn't work, by the way, then I couldn't take high voltage and change the frequency on you right in front of your face, right? But the fact is, I can. And I do it to people all the time. But what does that mean for my magnets now? Think about that. What does that mean for my magnets in a mag? Now I can change it and I can open and close the lock. Back and forth, oscillation, back and forth. Okay. That's the beauty of it. Once you learn electricity the right way and learn that everything's in there already, then you have it.
I
AC's
don't have, I did the wrong way. I
people go
know.
like this. They go, AC's like this on the sine wave, right? That's what we're all taught. That's not what it
Yeah.
is. It's push, 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 push. It's your AC flyback in slush. That where your magnet, that's AC. Okay.
Right, because that by definition is created by virtue of flux, and that
Yes.
is the flux. And what is the flux? It's north and south, north and south. So that is exactly what that relationship is.
Yeah. We literally, man, have everything in there to convert this properly. I could tell you
But
right
that
now.
doesn't that say it all though? Hold on. And I've been saying it all along that it's all 0 point action. You know what I mean? All you're doing is pushing the shit that's already there. Well, what do you mean already there? I mean, well, it's already there. Well, what's there? You know, the shit that's the fabric, you
Yeah.
know, the thing that holds everything together. The stuff where if you push all of it out, it all has to collapse back in, which is why you get it all under that circumstance.
But by the way, let me just say this because I got to say it while Sean's on here because there's a reason why different metals will have a different electrical value because of how fast they run on the surface of the metal. Okay. So when we go, copper has a higher resistance to magnetism, right? But silver doesn't. Silver has a lower resistance.
Huh.
But what if I use graphene? Okay. What am I looking for? What was Floyd Sweet looking for? What was the fastest metal he can put in the center of two conductors? That's what he wanted. What was the fastest rising thing he can put in between it? If you
Graphene.
put bismuth between two pieces of aluminum, you get 3 to 4 times the spike in energy level than you do with copper. Okay? This is why copper's bad in anti-gravity. You never want to use copper because it's slow. You want bismuth because it's fast. Okay? But what does that mean? It's more attractive to the environment. Okay? This is where it plays with entropy. Okay? It pulls in the energy from the environment faster, which gives us the rise and spike in energy faster. Okay? That's what's going on here. So when he's doing his energy, it's based on material science. Okay. He's using different materials in order to do it, but he's not the only one. Okay. People that find over unity systems, you're going to find certain materials in every single one of them, and they do not lie. Okay. Every one of them has a high voltage spike in it because you don't create energy, you pull it in from the environment. You are losing and pulling it in from the environment with copper. The only reason we use copper is because it's cheap. So when they tell you in ancient Egypt that gold changes the frequency, it changes how it acts in a system, it's because the speed over top of it is way faster than copper. That means it has a different value altogether.
Well, there is a you know, a material failure element to that as well. Now, in ways that we've discussed using bismuth in the past, it becomes inconsequential because it's contained and whatever. But with its low melting point and
Oh, no, no,
so
no,
on,
no.
you know,
Let me just tell you a secret here. It becomes superconductivity because of what you did to it. Okay.
well, I understand that
It goes
aspect
to a
of it.
lead state, but it's superconductive lead.
It's part of
It's
the
not
phase shift
not
fusion.
regular.
It's a new phase, and thus it's at cold or room temperature superconductive by becoming that quasi crystal or plasma ionized
Right.
state of matter.
Bernie comes
Not
in hot.
that does make sense, but it's a matter of sometimes getting it there, right? And that's sort of the
Well,
thing.
that's
It
the whole
sometimes it's
key.
kind of
That's
got
the
to reach
magic.
that failure point to be able to get its
Well, it has to do that phase shift. It has to reach that energy
the phase
level
shift, which is what
density
I'm saying.
spread.
Which
And
yep,
that's the key to it, and why modern science doesn't understand, because currently they need particle accelerators like CERN to be able to activate and to be able to strip the electrons and the interactions, ignite and overcome that plasma slash ionized energy barrier and density. And that's what we are restructuring with this plasma fusion.
amen. Yo,
Yeah.
do you
Hey,
see some
Shawn.
irony with this screen right now? You have like the two bearded guys over here, and then the two glasses guys over there. It's
All right, more Zen for you, brother. There we go.
We got to put in a woman in the center. We'll play Brady Bunch. Well,
right, exactly. Dude.
We're on the cool side. Cool guys.
Yeah, we
what was that tic-tac-toe game where they start lighting up the boxes everywhere?
Yeah.
Or celebrity checkers or whatever the heck it's called. I forget.
Yeah.
Yeah, it's not celebrity death match. I know that.
Definitely not. We're trying to avoid that one at all costs.
Celebrity death match.
Oh,
funny.
man.
So what are the next steps with these crystals? What do we do?
Oh, hold on.
Raise the frequency, find the threshold.
Well, we gotta first find and confirm the quasi-crystal aspect because by definition, if they are such, they do and interact with time dilation and thus present the possibility of time radiation dilation if you put too much energy into them, and a possible side effect, right? And that's how you don't want to fry yourself, even though it like confirms the matter. It's like, and you're dead like an alchemist of the old ages.
Yeah.
Okay, but,
But-
hold on.
If we do it right, I think that's like the warp drive aspect of the crystal or engineering, or the bubble of time fields, so that we could potentially develop it into a time machine. So there's that.
Well,
Hey, that's
so
the next
check
step.
this out. Remember how I liken this to like a black hole, white hole situation,
Mhm.
right? Well, what I propose is that the major fusion event, the self-sustaining one that I was talking about earlier,
Mhm.
that happens at that high frequency threshold that we don't know what it is and we have not reached, would mean the collapse of the two. Obviously we don't really know, but let's say we're playing a little thought experiment here. What happens when you take the white hole and the black hole and you crush them into each other? Well,
Singularity or a what's it called? A chain
no, you get an
reaction?
equilibrium state again. No, you get an equilibrium state again. That's it. What do you get? You get a gray hole. Where do we live in the gray? Where's the matter in the gray? All the matter's in the gray, right? So you're taking all the atomic mass, you're taking all the energy, you're separating them, and then you're going, all right, let's get this magnetic field at a high enough frequency that it keeps on pulling in. Because remember what I've said, the higher you crank that magnetic field, what does it do? It tightens up. That's what it does. It doesn't expand, it tightens up. And when it tightens up and then they cross, well, the same thing that happened by virtue of its creation, when the vectors cross, what do they create? A new third. But now it's multiplying like cell division. You see? So it's cramming, boom, and it's literally like a little swimmer hitting an egg. And then, that's what's happening. That's
Okay.
it.
Let me tell you something real quick about time. Okay, so you guys understand this? You do know that this experiment is speeding up time in that locality in order to make the conversion possible. So
Interesting.
think about this. When I slow it down, it's too fast for you to see, which means that it's speeding up time in order to break it apart, put it together in the right form, and then discharge it as your crystal. Okay? It's changing time already. You already have a time shift because you're basically using time dilation fields in different frequencies like we talked about, right?
Mhm.
So just understand that you already have time as a factor. So anytime you create anti-gravity, you're playing with time. Okay? But we're only time in one direction because the RAV doesn't go in different directions here. It's not counter-rotating like you think it is. It's one direction. You have to learn how to convert it to the other direction to change the time in the other way. Think about this too when you go to grow plants, okay? and you go to the impulse side of the field, you're now reversing that time itself in order to slow it, in order to change everything in there. Okay, just understand this. There's two sides of the coin. It has to do with how negative and positive energy actually work. Okay, because
So
it's
hold on,
not
let me
always
propose
magnet
this.
effect.
So let me propose this. So I agree with you, okay, about the RAV, but then what does that mean for the other side? And I always say that. So what does that
That
mean for
it's
the
a
other side?
definite possibility that Einstein
So
never saw
slowing you
coming
down on the
because he
other
didn't
side.
know it.
So you're
He didn't
speeding
know
up
it.
on one side and you're slowing it down on the other. Therefore, you have an ambient zero in the middle. Then
You
that's always
do.
been the point.
That's the
You have an
0 point.
ambient zero in the middle.
Yeah.
Yep.
And just a little off topic, but involved in it. Did you know that 1 amp coulomb so that's like your hot electricity or your resistance AC versus so that's 1 amp electron, I guess, from that. But the equivalent 1 electron of DC is 1.6 times 10 to the negative 19 coulombs. So it literally takes 1.60 times 10 to the magnitude of 19 electrons to make up 1 hot amp electron. So between DC cold electron and then your hot AC electricity amp, it's 10 or 1.6 times 10 to the 19 amount of electrons, like the amount of energy. So there's like the potential
All
with
right.
zero resistance of electrons in cold electricity converge compared to AC of that scale of waste. If I'm understanding that, is that possible?
So hold on. Are you converting electron? I get that electron word out of my mouth. I hate that word. The electricity to the amperage. Are you comparing the two, like converting?
But
Yeah. So
a coulomb is like a bucket. Okay, it's
Right.
1 amp for 1 second. So if you run 1 amp for 1 second, that's 1 coulomb. Coulomb's
okay.
a bucket of 10 to the number of 18 zeros electrons in the bucket.
Okay, so that I guess that's the density of 1 second of hot AC energy's worth of electrons. That's the density of the DC of electrons into 1 amp second of hot AC.
Yeah. So every second you get 1 amp, then you get another bucket of coulombs. Coulombs is an insane amount of energy. 1 coulomb. Insane.
Yeah, because that's literally 1.6 times 10 to the 19 zeros worth of electrons that have to flow in 1 second through that system to get that 1 amp, essentially, is what it is. So if it's cold electricity, a DC charged electron, then that would be I guess, the difference in resistance of heat that you'll lose from having the AC circuit compared to the DC within that second of those electrons, and then that percentage would be your waste, which it's just such a large number and potential for that. I don't know. Sorry, that's just one thought of the overall engineering of between cold plasma and hot plasma that I was doing over my little trip there, and
Very
yeah.
cool.
Oh, okay. Listen, you sparked something in my head that is irrelevant. Okay, but it just made me go, ah, damn. You know, 1.62 being, your golden ratio figure, okay, is mechanism of a spiral, is mechanism of caduceus relationship and motion, okay? And that's what we're seeing build out on the cathode side in the structure. See, I've been trying to figure out what the hell is going on, but it's helical, and
Mhm.
that's how it's building out is helical. So it's directly related to 1.62, which is directly related to time. You know, it's my theory at least, and nobody
Right.
really says it. I don't like talking about it because I don't believe it or know.
It's the time, and it's that second of time density, and then with specifically that what I was talking about, that factor is relevant in E equals mc squared for Einstein's, but that it has to do with the molar mass of the atom and the energy density in molar mass engineering into the particles and charge, as opposed to the speed of light factor in E equals mc squared, and getting into converting the molar mass of the energy atom and actually going straight into energy without having to factor in light speed variable slash constant.
Right. So I mean, if
You take it out to C, E equals M squared, no C.
Exactly, and replacing it with that time and energy or particle electron energy equation instead, density, and then you have direct conversion of mass into energy through electron charge numbers of specific amounts, right? So, or volume of units of the particle, base particle charge of the electron into it.
yeah, I hear that. Yeah, that makes sense.
It's because light's an effect; it's not a cause.
Right,
That's why you have to.
exactly.
That's why you have to take it out of there, because that made no sense to put in
That
the
was
first place.
skewing of E equals mc squared. Where with this, it's direct nuclear density charge energy of electron being the charged particle that makes it up, and a similar magnitude of to the 19th on it. So, yeah, just a thought, a little bit more work going into it, but just the initial thoughts on
I'm
that.
going to show you something real quick because I don't think people picked this up. Okay, we showed this earlier, right? I just want
Did you
to show
catch
you
a presentation, Bernie?
I sadly fell asleep after my plane flight. I meant to join in and stream from the beginning, so this will be new to me, but rewatch, and I'm going to rewatch the entire thing after.
I'd love your opinion after you watch it.
Okay, hold on, right here. Just want you guys to pay attention to something. It's the distance between energy. On the bottom, they came out in a drum beat, okay? But in the top, they didn't. They come out as high frequency. Just understand this. These are equal spaced the whole way down. That's your harmonics at play. Okay? No matter what you do, the beat frequency is in a harmonic value. Okay? So we can listen to it and you can clearly hear the beats and it's in harmonics while the other one's in high frequency.
Which, by the way, that is representative of your ratio.
I'm sorry, what?
I said, by the way, if you count all that out, that's representative of what your ratio is, one to the other. You know, which if it's functioning the way you want it to, then you know that that's your sweet spot. If when you hit the sweet spot, you count how it's breaking up.
Yeah, I'm going to tell you this right now. This is in AC, by the way. This is not in DC. Just watch. Right here on the bottom. You hear that right at the end? That's your beat frequency.
Whoa, 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 whoa. Mm-hmm.
That right there. You just have to understand it for what it is, guys. That's how you know you're in AC. DC does not do that. Okay, it's the slush. The slush between the two is creating your beats. Okay, I'll play it again so you guys get it.
It's there.
It's just that little bit. That's all it is. But so let's tie this back together. We always talk about harmonics. We always talk about resonance. Okay, but they're all tied in. I mean, that right there is telling you exactly how it's tied in between everything.
because
You
you
know
have
what?
your
I'm just making that sound, man, in my head of that beat frequency, and I'm kind of like counting it off as to like what it seems to be. Seems to be pretty close to like 7 hertz, man.
And
Like
by
it's
the
like whoa,
way,
whoa, 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 and I'm sitting there doing that, and like kind of being like, "What's about a second?" I'm like, I just did that about 6.5 times, and I know my timing is off. So I'm sitting there saying, "Man, it's low frequency and it's close."
you're gonna have to listen to the video I sent you because you're missing a lot. You're only getting maybe 30% of what is coming out of it. It's tuning in as like a radio transmitter and receiver. It actually sounds like a shortwave radio. That tube that's been ionized with the plasma. I thought it was like outrageous. How is this tuning into as like an AM station running through the frequencies and then stopping with some kind of scatter? Like it was demodulating an AM channel. And I'm just watching this tube filled with plasma going, what is going on? Now I know people say, oh, plasma can be used as a speaker. That's true. But this was not being a speaker. This was being a receiver and a demodulator and a
the
transceiver.
radiant frequencies, right? So it's the radiant energy and the bandwidth of the plasma arc, I'm guessing, is your wavelength in the signals that it's accepting in. And then that's what's then resonating, scattering between the two and giving you that
Full blown
resonance.
agreement with you, dude. That read my mind. That's it.
Yep, that makes sense. Yeah. It's so yeah,
I,
even though Nathan did a good job with the sound, you got I'll send you guys the video, whoever wants me to.
Yes,
Um
please.
yeah, are you on Facebook, Bernie?
I believe so. Send me everything.
Messenger?
I won't publish ever unless you let me, unless I ask and you tell me yes. Everything else I keep and we use for science only, private.
okay, guys, just understand that,
I'll
Shawn,
connect
your
later.
spectrum analyzer picked it up. You wanted to know what they were. There you go. That's what your
That
spectrum
was for the
analyzer
RAV.
picked up.
That
You
was for the
said AM
RAV.
radio station, dialing it in, looking for each one of the peaks in the resonance frequency.
It,
You just picked it up in your spectrum analyzer.
yeah, it looks like it matches up now that I'm like, yeah, yeah.
And the reason why I heard it is because it's in the radio frequency range, the
Mhm.
AM frequency range. So yeah, I'll have to put on the spectrum analyzer for that
But to just
experiment.
understand this, all the legends, all the stuff that comes up, the history, all the stuff that we learn, it's all true. You just need to
Oh yeah,
know how to put them together.
more and more.
Now we know. We're literally with this one project putting it all together.
Yeah.
It's the God code. It's plasma alchemy. It's structure of the universe. It's all of it. And it's Nikola Tesla's understandings and applied with Walter Russell's.
But by the way, Shawn's doing water experiments now, Bernie. So for you to
We
come
gotta
in
do
and
some private group work for
I got a
sure.
water RAV.
yeah, so you coming in at this time is like
Yeah.
perfect for like to you get a Yahtzee moment between you and Shawn. You know what I mean?
Yeah. This has been needed and expected for a while, and now it's happening. And also, I will
Yeah.
be in California on December 12th. I fly out.
Nice. Just in time to see that what's it called 3i Atlas come through, huh? Right before
I
Christmas.
guess so, right? If the world's ending, I'm gonna be in LA of all places. Woo!
Yeah, that's probably the worst place to be, man. That'd fall right into the ocean.
I know. That's the
Yeah.
joke.
Well, they have that big telescope out in LA. Would you be able to go there and check it out?
Well, I'd be up in the hills and mountains regardless, because apparently there's some people freaking out, being like, "Oh, it's gonna cause a tsunami on the west coast," and I'm like, "Well, I'm there. Might as well
See
go
if
and bang."
somebody's got
I'll be on the mountains just in case to survive. Up watching it.
Mhm.
see if somebody catches a video of it. You know what I mean? And then
That's
play
gonna
it
be
for
me,
us
bro.
live.
I'm gonna be filming it as live streaming it from the top right before the networks go down, so the rest of the world can see. Right? It'll be like,
Hey, you
yeah,
know you're gonna be up there with like some people like some like hippies with like hairy armpits and like belly dancer skirts on,
oh,
like
you're talking about
worshiping it and stuff,
Sasquatch?
you know? Like, I
Yeah, the
mean, listen, I'm not,
Sasquatch.
they're pretty cool, you know?
Oh my God, dude.
Oh,
But back in the 80s, it would be a bunch of women coming out of the VW bus. Now it'd be a bunch of men in pink tops.
Yeah.
LA's
Right.
changed.
Right. Right. Like 400-pound guys
I
with
need,
like, flip
need
flops
a
and
weed
socks.
moment after that. I gotta forget that. I need my short-term memory loss. I'll be right back.
Oh, I got to get that picture. Bernie's so disappointed when the VW bus shows up. That'd be hilarious.
What's that?
Would be.
Oh,
Well,
Shawn,
my
this is,
friends,
dude, I know it's close to your time. I just want to tell you, dude, it's amazing to have you on here with all of us on
appreciate
here.
it.
That-
Thank you.
Even if you don't want to present next time or something like that, if you just want to come on the round table, man, it's
Thank you.
awesome to get your perspective on this stuff. Especially because Joe and I usually just go,
Appreciate it.
back and forth. It's really awesome.
Yeah.
I think the chat loves it as well.
Thank you. I appreciate that. I'll take you up on your offer. That means a lot. Thank you.
Yeah, man. Anytime you feel up to it, please. Like, you ought to.
Appreciate it.
We're talking
Yeah,
about your work anyway.
Yeah.
thank you.
Like, for crying
I'm
out loud.
honored. I'm so honored. I really am, guys. I'm humbled by your kindness. Thank you. Means a lot.
Yeah. And just so everybody out there knows anyway, like, and I truly mean this, and it should, I believe and have relentlessly believed in this RAV since day one, once I've
Mhm.
realized what it was doing. So much so that I've actually kind of lost interest personally in most other things that touch on these topics, because
Oh
to me
wow.
it's just a less effective version of what we're already doing.
Yeah. No, I agree
So,
with that.
right.
So
So
for
it's like
me, since the
and
beginning, I feel the exact same, but I'm more interested in my own stuff and Rav because it's one and the same, and I'm like, this is it, and
so
it's the
right.
connecting part of
That's
the
So,
awesome.
phase
right. So
shift.
what you're saying though
Season.
is perfect because it's true, right? Like what you're focused on, is like within the path of it. It just hasn't gotten there and reached it yet. Well, but it has now,
Hey,
sort
hey,
of, but it hasn't, whatever. So
Shawn's
you
got to
get the
go,
gist.
guys.
All right.
Much
Shawn,
love, and
thank you, my friend.
Sean, be
Yeah.
well, buddy. We'll talk.
any Shawn
Thank
episode
you.
multi-stream to my channel from the get-go because I will try to be joining them and let me know ahead of time and I'll plan to be there because we need more Shawn,
Okay.
and Shawn's work is top notch. Always an honor and pleasure.
Love you,
Thank
Shawn.
you. That means a lot. Hey, before I go, Nathan, I put a video
Yeah.
in your uh, Facebook, and it would be great to hear Bernie's analysis on
Send it to him.
when the RAV turns into that bright light RAV because it's a plasmoid in water. So it'd be interesting to hear his opinion on. I just sent it to you, but you're correct.
Yeah,
I
if you
have to
want it right
go.
now, here it is.
Yeah. So um, what happens with this is that the plasma starts to gather below, and there's water in here. So um, superheated heated water. When the plasma collects on the bottom, it then starts that spinning plasmoid, and you know when it's spinning because it turns to a bright white light and it's condensed. See, it's
I was
condensing
gonna
there.
say the bright white. As soon as it gets to bright white, that is when it's at full energy hydrogen, and that's when the fusion is able to happen and starts happening on it. And that's
What? Yeah.
the length between the arc there of the tube of the plasma, that's going to be your wavelength of the interactions for the resonant frequency of that plasma fusion.
Yeah.
Baby, look at that thing go.
You see how white it got?
Oh yes. So
That's
and
spinning
that at
plasma.
that point, there's a good chance that any of the atomic hydrogen that's being formed in there is being
Mhm.
transmutated into helium, and that if you can collect the gas as
Whoa.
samples, that would be a new
Whoa.
verification of the experiment I did with Jeremiah a few years back in that. And it's every time it goes from orange, yellow to white that it supposedly is doing that hydrogen to helium.
Wow. Thank you. Awesome. I wanted to know
Thank
that.
you.
Appreciate it. All right.
And I
It's a
got some
pleasure,
Mets
guys. Thank you so much.
Catch you later, Sean.
Okay, thank you. Bye. Love
Godspeed.
you all.
Hey Bernie, you know what he
Bye.
showed that you would have liked, bro? It was really cool. He put a RAV on a salt. Was nice business. He put a RAV on a salt crystal. Okay. And after the RAV built up and reached full power, the thing started throwing up sodium light, door yellow.
Okay, yeah.
I was
I
like, yeah, that's not the easy trick. That's a
That's what
hard trick, man.
definitely want to see. And so the star in the jar replication, that's actually what I'm going to be setting up next. Probably when I'm down with Nathan in a week and a half. The sonoluminescence, we're going to be doing fusion just through acoustic tones, and that's part of what I was working on while out in the Okanagan with my sound engineer, music producing friends, where we were taking the tones out of that the quantum intelligence was giving us and then turning them into tracks to play through the speakers to trigger the star in the jar sonoluminescence. And from one tone slash light, I guess frequency slash energy slash I guess elements. That's the key, is that it should be able to transmutate elements from the hydrogen at the white light state, and by putting in the additional colored sound tones, be able to get the other gases out of it in a more stable point of transmutation, by switching the flame color, plasma color of the sonoluminescence within. But we'll get more into that in a private conversation. But either way, that's another major part of what I've just been working on.
Very cool. Yanni's saying far out, scary, keep safe. It's all true. That
Yes,
said,
one Bigman, you just got it.
what Bernie was just saying, definitely. But also what I was just saying too about what he showed us. You got to remember, if you've broken all the sodium off of the salt, that means that you're throwing off chlorine.
Chlorine as a
It's
compound.
not doing anything with the chlorine, and you're getting chlorine gas.
So it usually so it actually will usually use part of the anode or the cathode as in a salt water reaction. It'll take the chlorine and make a compound out of it instead of a gas, from what I found.
Yeah,
So
in water, but he's not doing it in water.
oh yeah, if you're not doing it in water, then hopefully
Yeah, there's nothing to catch it. No.
But, okay, yeah, then he's got to have a tester and do closed reaction, try to capture and test, because very open.
I should probably
open,
message him.
ventilated.
I don't know that he realizes that or not.
Yeah, so that's a very good point there, Joe. And
Yeah, because in open air, it's not doing anything with that chlorine. It's just off-putting it.
Yeah,
That's
so
it.
he's got to be ventilated and have gas mask, proper breathing, if doing that, around him whatsoever, for sure.
Yeah, that could make you stop breathing.
You might want to get that information to him fairly fast.
Yeah,
exactly. Yes, indeed. Shawn, if you're listening, take this into consideration. And even if you are listening, we're going to message you right after this to let you know again, just because we like you being alive.
Yeah.
That's all I'm saying.
But a very valid point. That is time sensitive.
I'll do the messaging right now.
It's a good idea.
Greg, it just needs to get to him 100% before his next run of experiments, which hopefully aren't right now because he's inspired after doing the thing, but I think he was busy.
Well, life contains a lot of information. You know what I mean? Sometimes you hear all the things and then you say the things and then you realize other things and you're like, son of a bitch.
It takes a moment to compute and be like this, right? I get it. Exactly.
Mm-hmm. Yeah. Well, anyway.
Very, very crucial, valid point. So equally, I was actually covering that with my friends, a couple of my friends while out in the Okanagan, while going over some of the chemical reactions and explaining the first reaction is gas dangers, whether it's stepping up from the 5 volt that I do to 12 volt and 1 amp, where you get magnitudes of gain in exponential gain in the level of hydrogen gas alone you produce. So from the low levels I do with my threshold to instantly within a few minutes, you're going to explode the building or the backyard that you're in just from the density of level of hydrogen that comes out of it. Or inversely, the other aspect of the gas, like you just said, the leftover gases that in the reaction that can turn into very, very poisonous gases and dangerous gases on the I guess the leftover part of the chemical reaction, and that's a crucial danger of it. And then the second degree is when you're getting the particles, the physical parts of the reactions, that whether it's an oxide, and then they're all nanomaterials, so you get large amounts of oxide that if you touch or absorb in, that all of a sudden becomes a poison of heavy metal poisoning very quickly. Or then the next step up, that certain chemical reactions just with water, if you get instead of H2O, a lot of them are just it's very reactive because it's unstable, but you'll get OHO instead as part of your outcome. And a lot of the time it's OHO negative or OHO positive, which are well, those are hydrogen isotopes, aka very unstable and very reactive half-lives of radiation that you will get out of this simple small electrochemical reaction into water. And another way that a lot of ancient alchemists and even modern cold fusion, RIP Martin Fleischmann, get radiation poisoning and cancer from exposing it without knowing. And then there's the next level up of the plasma nuclear reaction of hydrogen that you might trigger the H-bomb or something. That it's like every single level of water electrolysis chemistry, there's extreme dangers if you don't know what you're doing. And like you just pointed out, there's another major additional part of that chemical formula is with salt, you have the sodium and you have the chlorine in that molecule, and that is part of most of electrolysis reactions. So that's another key part that you need to always have in the reactions when you're doing this and equate for before conducting the experiments.
All right, Nathan, I need you to try something because you're going to see what I saw, and I just realized this. Listening to BurnEye again. Take one of your used RAV clays, okay, that has nice tunneling on it. Put it in water and leave it there. Clean water, leave it there. Okay, because I did that with my rock. Okay, and do you remember I told you that there was like some kind of like slime crap coming out of it? Well, I dumped it, cleaned the rock entirely, like soap and water cleaned it, I soaked it in acid and stuff to make sure it was neutralized, and then back and forth and rinsed it with a bicarbonate and stuff just to make sure that there was nothing like that would cause it again. And then I went and I soaked it in water. Now, when I came back the next time, it wasn't slimy. All right, but what it did have was growth inside the water that now that I'm realizing it looked like gills. Okay, and the gills looked like the dendritic, accumulations that Shawn's seeing too. So try that out.
Sorry, my mic was off. Yes, like Shawn was getting exactly.
Yeah, and then I just realized that it was like the same dendritic because, like I said to myself, I was like, it looks like gills. And I said earlier today, I was like, oh, it kind of looks like I forget what they call them, but the salamander gills, the external ones, where it's like fingers, but then fractal fingers off of it.
Oh,
Yeah,
it looks like that.
Yeah, I know exactly what you're talking about.
So hold on. I just want you to just take in the moment for a second. Bernie ran through all this stuff right here. So we're actually doing the work on the RAV and stuff, and he's doing it in the water. So what we're doing is laying down the way that the energy works going into the periodic table and how it actually builds out the elements and what it looks like, not theoretically, but what it physically looks like. Just understand the moment that just happened right there so we can all appreciate it for what it is. When this combination comes together, it's going to be just absolutely out of this world. So,
Experimentally proving and
yes,
demonstrating.
we're going to have everything so physics can go through it and get it right. We're gonna be the example of these are the tests you need, which is what they sorely needed for a long time now. So I want to give a shout out to Darren here. He gave out one Old Man Build membership. I want to thank you very much, Darren. He also gave a sticker earlier, man. Darren's awesome, brother. Thank you.
Yes, thank you.
We
Yeah, man,
actually have
what a time to be alive and a part of this group. You know, out of all the people in the world, we're the schmucks that were chosen.
Well, the
You know?
Sharks have been figuring it out, and we're doing it for the noble cause of real science and advancing humanity, not controlled by $300 billion of funding at CERN that can accomplish what we've been doing in a few years' time here, and a few $1,000s compared to 300 billion and 35 years that they can get shit done. And yeah, so
but
there might be some
think of the
resistance.
next level where this goes. I mean, you're jumping from like a type 0 civilization to a type 1. I mean, we're immediately leaping, you know what I
Yep.
mean, into this.
Exactly.
Yeah, because now we can take things and oh, I want to see how the solar system reacts. So let's do this, this, and this based on this experiment, right? Now you have the experiment to go and try it. It's not all the same experiment. We're not taking one laser and hitting it on 4 different directions and calling it something different. We're showing how it builds out so you physically see it. Then you go, okay, now my interpretation for my next level of questioning for this is much better. Now we build it out much better, and you go, okay, dude, that's what I'm saying. It's different level altogether. But like Bernie said, just have caution in what you do, because this is where you have so much information that it could be very dangerous for everyone to do it. And this is probably the line that they didn't want us to cross, that they already knew had been crossed in the 50s.
Yeah,
This is
right.
the line.
With ionic, or so it's static, or sorry, static electric confinement fusion, I believe it is what it was called, IEC, or yeah, no, inertial electrostatic confinement fusion. That's what it is. Inertial electrostatic confinement fusion, IEC fusion, was what it was called, and it was classified immediately after the H bomb, and that's exactly what this is. And with the dangers that I just gave there and listed, it's all extremely real, accurate, and it has to get into the forced state of water, how water charges and the isotopes it forms from that negative positive charge and cell structuring. And then when you're inputting, and another key part of what I figured out in my recent work and writing out and understandings is that I'm not just doing a particle accelerator, but don't have to bring it up to the speed of light, just have to do the specific lines for the spintronics. It's also essentially a energy or particle or quantum qubit particle generator aspect. So particle accelerator and generator that we are going to be demonstrating, and what's part of what I've been engineering here. And there's just so much more to it. But point in wrapping it all up, I've known these dangers, I know these processes for 12 years since the beginning, when I initially crossed the barriers and experienced firsthand successful transformations in fusion, only to have them unstable because I didn't know the full processes at the time, and then had the radiation, the half-lives, the decays, the nano oxides, poisons, different stuff. And it's like I got very, very sick each time and like almost died, but realized what it was, then confirmed it with others, and then didn't cross these boundaries again until I get to a safe spot, safe understanding of the processes that we now have, and setting up safe experiments. But it's that at any point in the last 12 years, I could have done the next generation of experiments and easily proven how easy this stuff is and proof of concepts with everything else. But number one, it's dangerous to my own self. But number two, with with huge power or huge knowledge comes huge responsibility, and it's that some of them are so simple that when fully understood by nefarious actors, especially nation state nefarious actors or resource groups, that it could bring a very quick demise to humanity.
Hey,
And
Bernie,
Earth.
Bernie, listen, on a
Not
lighter
level.
note, and to show you the transition of it all, right? I started a painting today. All right, I'll show you. It's like not very close to done, but you see, it's the Virgin Mary, right? And you see, she's accepting the Jesus star that's over there, right?
I love that.
Well, that Jesus star is the RAV.
I
That's what
think
symbolize the RAV.
to leave it
Yeah.
like that it is finished, because I got to show you one that I got very similar of accepting, right? You got the blue face of this.
Yeah.
One day we will
Very
all
similar. Yes.
be free, right? And it's a beautiful thing.
Yeah, it's literally the symbolism of the two parts. You have the Virgin and the child of the Virgin. It's the two parts, and kind of like walking, like piercing the firmament, so to speak. And then
Eternal.
represented by a grotto. I try to make it like an old school, like Italian statue, like a garden statue, like the Virgin Mary in the grotto, stepping out and accepting the star. I thought it was cool. I don't know.
I love
But
it.
yeah,
I
probably gonna take a good long time to finish
No,
that. So
no,
I'm only on
leave
like a
no,
day
that is
thing.
finished. That is finished, and I need that one the way it is to put up next to the other one, and or I have to, like we gotta find a way,
I'm too
because
stubborn to call that finished, brother. That needs
hey,
another 50
our
layers on top of
creativity
what's already been
pieces
done. And
are finished when they're unfinished, and the fact of the identity, like the similarities and parallels.
yep. And actually, it's funny because this is only the half version. I have one that's double the size, but I wanted to do a small one before I committed to the bigger canvas.
Exactly.
And
So I will take that small one as finished, and then you're going to start on
no
the
problem. You can
larger
have,
new one that you want to do all the way. That's going to take a long
so,
time.
but
But
hold
I
on.
get
But
that small
you
one
know
one
where
day.
my
We'll
the
do it
full
right.
one
We'll
is
do it right.
similar. Okay, is that the full one has her stepping on the body of the snake with the head of a lion. Like you know, it's really
Right?
cool.
It's ancient
Yeah,
alchemy.
trying to
Oh
go like a
man.
little Gnostic on it. Little.
Well, the snake represents the charge, right? The current of the flow of the electron, the wire, and then the lion head, or like stepping on the lion represents the hydride formation out of the electrochemical electrolysis reaction, and that it's on the anode side, the sacrificial. That's why it always bleeds with the
Mhm.
lion head, and that's the gold
Well,
as a
it's also
sacrificial.
like a nod to the demiurge too. Like the demiurgos. The fool that thinks he's the creator, the brilliance, the chosen.
Exactly. us, everyone watching and everyone
Then
here.
there's irony built all over the place. I mean, but I don't. That's neither here nor there.
Exactly.
I like it the way it is.
Right? So I'm getting that small one. Everyone in the chat, put a 1 if Joe needs to send me that small one, leave it how it is, and start on the new big one if he wants to finish all the way.
I love
Okay.
No problem. Listen, when it's done, you want it. Once I'm done with both the small one and the big one, I'll send you the small one. There's no
The
problem.
big one is yours, and the small one, absolutely send it when they're both done. But just start on the big one because we have a lot of work to go, and don't worry about the small one. She's perfect.
Oh, you gotta
Right on.
love it.
It's gonna look good. My
Happy
realism
Thanksgiving,
is
my
getting pretty
friends.
good. I didn't show you my Dorothy. Hold on, check this one out.
You got to make sure you put it in some part of your background there, Bernie, where we can see it.
Oh, of course. I'm gonna have both of them centered up in front. Then once I get that, I'll
How's that, Dorothy?
Oh wow! Look at that! Look at you
Came out
go,
pretty good.
Joe.
I know.
Joe's got mad talent.
It's like I figured out how to do something one time.
I'd say more than once. I'd say every time you pick up the drawing and painting tools.
Something like that. Yep, but that's the story. That's what I got going on.
All right, we at least got one, if not more. So, we got no 2 so far. So this is democratic, real science, real truth. So we got to do what please the audience there, Joe. So we just need 3 more 1s so we can have overwhelming majority.
I could only want, but all you had to do was ask. You didn't need any sort of democratic vote.
All that matters is your vote, and I love you, Joe. Thank you.
No, Bernie put up all the ones for everybody. Look at him. He went to everybody's thing on there. Yeah. That was awesome, Bernie.
All right. You got it, buddy. Nice. I gave you the 3rd.
He outvoted everything. Look at him. The whole chat is burning. Joe gave him 1. That's amazing.
Oh, well, that's the vote that matters. Amazing. All right, my friends. Hopefully, we'll see you right away over for the start of League of Extraordinary Adventures. And I know
Mike's out tonight.
Oh, he's out tonight. Okay, well then, do you want to just send me a link to the Friday night stream with Traveling Fools? Ask them if that's all right, and then happily join there.
Nice. Yeah. Oh, I forgot that. I gotta announce everything at the end, right? So
perfect.
Yeah.
Well, let's do that then, and make you the large and in charge announcement.
Large and in charge. Hey, don't say that, man. It was so funny. I told my wife, I wrote an equation for gravity. She goes, "Yeah, that's because you're fat. You understand gravity very well."
No, we're gonna go like I wrote the equation, honey, to explain the experimental demonstration of I'm fat.
Yes, the demonstration of it. All right, guys, I just want to say thank you real quick to Darren. He gave a $5 sticker, man. Thank you very much. He also gave another Old Man Builds membership. Guys, totally awesome. We're doing some awesome work around here. Stay tuned, man, because this is only going to get better. And we're not coming off of this topic for a while. There's a lot of stuff in there behind the scenes that we haven't shown that slowed down. We were looking at the best way of presenting it, to do interviews and stuff like that throughout everything that we're doing. So anyway, with that said, guys, I want to thank everybody for watching today. I'll be on Traveling Fools channel later on tonight. Don't know what the topic is. I don't know what's going on. I missed everything with Thanksgiving yesterday. Kind of messed up my whole schedule. So with that said, I want to thank everybody in the chat today. I want to thank Shawn for coming on. I want to thank Bernie for hanging out with us as well. Joe, always thank you to you, man. With that said, have a great day, guys.
Peace and love.
The old man built. The old man built. The old man built. The old man built. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Fear Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.